Good morning, all. So, welcome back to the lecture on process planning cost estimation, unit number one. Myself, Murli Subramanya. So, we were discussing about computer-aided process planning in our last video, which is all about retrieval system, right? What is a retrieval system? The process plan is the standard process plan being stored in our system or in our database. When we receive some new product or some new order for new design or new part component, what we need to do is we need to code the particular product with some unique numbers. Like we saw part coding and classification system example, its coding and classification system depends on its external shape, internal shape, whether holes are there or not, whether what is the length by diameter ratio. Based on that, we need to assign some numbers. That is part coding and classification system. One example is OPIT system. So with that, we have to give some number, unique number, identification number for one product once we receive some order. Then we have to check that number with the database because similar way we done our past work and stored past work for that component and prepared the process plan, executed that production manufacturing. So that overall process plan for that individual components are stored. So once we receive that new component given a code, we have to match that with our database. If similar database is there, not say, if same database is there, fine, we can directly use. If not, similar database is there, like a few features are different from the standard process planning available in our database, then the new product in the sense we need to retrieve that the standard process plan and we have to see what kind of changes in the product features. Accordingly, we need to change the manufacturing process or assign some machine tools or resources, human operator tools and all. Then update the standard process plan, modify the standard process plan and store them in the again database for future reference for other orders. So once we got that, then we can able to proceed to production. If standard process plan not available to the new product, like not even similar, then what we need to do, we need to prepare from the beginning and store it in the database for future action. So that is what we saw. And also we saw some its classification system and example. So in another approach is generative type computer aided process planning system. So here, rather than retrieving and editing an existing plan from a web database, we need to create a plan from the scratch in systematic way. Okay, with the knowledge of a process planner, of course, it should be there. So we need to prepare a new process plan rather than retrieving. That is what generative type computer aided process planning. In fully generative computer aided process planning system, without human assistant or without predefined standard process plans, we need to create the process plan. Means knowledge of human assistants or human process planner needs to be pre-gathered according to their expertise and knowledge. The information from them needs to be gathered and we should be making kind of rules and logics and we prepare a system for that. But when we do the generative type computer process planning, we should not use any human on that particular time. Without any human assistant or even without having any predefined standard plans, we should create generative type computer process planning in systematic way. That is what the difference between a retrieval type and a generative type. So it comes under designing the of generative computer process planning comes under expert system, artificial intelligence, we can say. Okay, so we need to use computers for that. So if we go with the expert system, means mainly three components are there. One is knowledge base, and another one is computer for understanding the parts, and also inference engine or working memory kind of thing, we can say. So knowledge base contains all the information, technical information about what manufacturing or what are the manufacturing process we are having in our industry, how many machines are there, what is the functionality of the machine, and what kind of rules we need to make or logics we need to make. So all the information we gather from the past experience from process planners or experts, and capture their information and store in the computer program in form of codes, which the machine control unit can able to understand. Okay, this is what knowledge base. We need to build complete knowledge base. It's include like who are all the suppliers for our industry, who are the clients for our industry, when they need to be, the component needs to be stored, or if we are purchasing the raw material from one client, then how long they are going to take to deliver, how much product we already ordered, and for example, past 4 or 5 times we might have ordered something. All the times, not necessarily they might have delivered on time. Maybe 1 or 2 times they might be having a delay. So we need to make some decision on that, right? So for that, that knowledge is very very important. So complete knowledge with the supplier, as well as alternative plans like other suppliers information, how the logistics are, and not even that material, raw material purchasing kind of thing. Once we are making, how many number of machines available in our industry, what are the tools we have, and what are the human resources and their knowledge, like workforce knowledge, experience, and we need to have those kind of information. Then only we can able to plan. So all needs to be stored in some form of code for the expert system. Uh, so to understand, so that is what the knowledge base. Okay, and computer also needed where it should understand the drawings which we are giving, and sequence of operation it should be done. That part design, from the part design information, the computer should be able to capable of doing or providing the sequence of operation to be done, instead of having a one process planner to say that okay, first do the turning operation, after do the threading operation. It should give automatically. That means that knowledge, that capability should have. Then inference engine, that inference engine should will be having a planning that create the algorithm from the knowledge base, and it will give some actions for doing the activity. So inference engine is main, where it provides rules, and also it provides some algorithms for performing. So mainly it's based on logic. Various logics are there. Decision tree is one. In expert system, decision tree is one of the logic system, or through decision table. In the decision table, conditions and actions are placed in rows and columns. Means condition actions are placed in rows, decision rules are placed in column, and AI-based, artificial intelligence-based approach, asymmetric approach, like various approaches are there for process planning under generative by computer process planning. So simple example, I'm not going in detail about this. Decision tree, one of the example is decision tree in order to make some hold on the component. So once we give this component part design to that part design with some features and tolerance information, that part introduction is called as a root. Then we need to make a decision, either it is a rotational component or non-rotational component. If it is rotational component, we need to go for process E1, and if not, we have to go for E7 and next node. Okay, kind of other process in non-rotational component and its machining process before. If it is rotational component, we hit whether we need to do what, whether we need to make some in rotational component we need to do some turning or we need to do some hold kind of thing we need to have. So if it is a hold, if there is a hold, then we need to go for E2 process, and if not only we need to go for E3, and which leads to A4. A4 is a kind of machining process. So once we reach the E2, then it will go to the next question, that is node 1 is rotational component. Pole in the sense it reaches the node 2. So it's a node and root basis. So node 2 is the N2. Then where pole is there and what is the tolerance requirement, whether we need a tight tolerance or moderate tolerance or heavy tolerance. So depends on that we need to define machines a little bit. Okay, whether a super finishing kind of process means it will be number B or C. Then if we need a tolerance greater than 0.1 or tolerance we need a tight 0.005, in the sense we need to have a better reaming process kind of thing. Otherwise, normal drilling machine, drilling tools. So in order to make this decision tree means that this kind of logic will be processed in our expert system. So once we give the part design, the knowledge base has all those information, assuming that the tolerance value greater than 0.101. In the sense, we need to choose drill bit A. Like that, this knowledge base stored in our computer. Once inference engine get this kind of information, it makes the logic. Okay, if this is the condition, then do the action like choosing a drill A. If not, go to the drill bit A2 or A3, like that it will go. So this logic is being generated in the inference engine. So working memory will be keeping what kind of action is happening at that particular moment. Okay, so that is also very, very important. So that is what is one kind of decision tree and its understanding. So artificial intelligence, basically it's an expert system. Again, it's based on the formal logic and production rules. And if example, there is a declarative knowledge is there, so which represents some information, like assume consider like this example, depth, code, what is the size, like that. So first order predicate calculus has well formed formulas like WFF, like this declarative knowledge, like we need to define kind of attributes of our what to say, our features of the particular product we receive. How much depth? What is depth means what? Whether it's a slot or it is maybe undercut or something, but depth underscore hold. So it should be defined like the value is 2.5, like that it is going. So this kind of declarative knowledges, or we need to have a procedural languages. What is procedural language? If then rules we need to make for production. So, okay, if the component reaches this particular diameter, like 20 diameter, then we need to do some threading. For example, we have a 50 centimeter diameter shaft. Once we do the machining turning operation for 10 centimeter, then 10 centimeters the diameter we removed, in the sense totally we have a 10 plus 10, 20. If we remove means 30 diameter shaft will be there. So once we reach 30 centimeter shaft, then we need to do the threading. So if then loop will go. Oh, if the diameter reaches 30, then do the threading operation, like that. So this kind of procedural language will be there. So for that we need a, as I said in the previous thing also, like we need an inference engine. So that inference engine only make formal logic and production rules based on our knowledge base. So in knowledge base we have a procedural knowledge or declarative knowledge kind of thing will be there. So the knowledge base contain all the information, but the instruction will be given. So all this comes under your inference engine, which generates the process sequence for manufacturing a task needs to be completed. So another approach developed by MIT Laboratory Manufacturing Productive is axiomatic approach. So here also they do some logic framework for designing product and process, but here they mainly based on the surface group. What is mean by surface group? Assume like you have a component with multiple surfaces. Something again, it depends on the design of the particular product. So depends on the design and how many number of surfaces are, what are similarities available on the particular surfaces, or grouped together. For that particular group, they may be assigning some set of machineries, one particular machine for that set of group. Then similarly, one component might be having n number of surfaces. That n number of surfaces can be grouped into small subgroups of surface groups. So each group need to have one particular machine. So like that, if we group surface groups by analyzing the various surfaces. So for each and every surface group, if we started providing a machines for continuing the process and optimizing that based on collected information, which combination of machine is good for the particular surface group in order to complete the process very quickly, efficiently, time consuming way. So all this will comes under this process or this approach is dealing with the surface group. So this is another way of doing the computer aided process planning in generative way. So ultimately, if I say generative type computer aided process planning, assume we have a plan already. We have a plan. If we want to do some task, we can refer the plan and perform. If we don't have any plan stored in our system, if we receive some task with us, what we need to do, we should plan something. We should make some logic or frameworks. Further, we should have some knowledge. So that's what we need to build our knowledge base first. And from the knowledge base, we need to extract some information and check the conditions. If then the logics, then we need to provide some actions for that. So each approach, like AI-based approach or expert system-based approach or axiomatic approach, providing with the background of knowledge base, inference engine, working memory, and logics. Okay, so we need to understand comparing with generative type to retrieval. If I compare, easiest way is retrieval type. Provided in retrieval type, we should be having a standard process plan. So consider one company going to start its production now. They definitely not having any production plan or process plan. So, but they have experts. They will be having experience. They might have having process planner experience. One, they may be recruited from other industries. So, what they need to do with them, they need to prepare a standard process planner too. But initially, they might be taking longer time in terms of retrieval time or variant type. Okay, so longer time to do prepare some standard plan in store. But initially, they provide some sufficient time to prepare a standard plan, process plan, and its database. In future, it will be easier for them. Or every time if they are depending on generative type computer process planning, like whenever they are receiving one component, new component, every time they are doing this approach, it's like a time consuming process. Okay, so mostly industry go with the mass production or medium scale production. In that case, better to go with the variant type where storing the process plan as in the database as a standard process plan, retrieve it, and needed means we need to modify something and perform it. Okay, this is the difference between generative type and what is it retrieval type process plan. Okay, so with this, I like to wind up this video. In the our next class, we'll be discussing about make or buy decision and break even point kind of topic, break even on this kind of topic. Okay, thank you.